Hey Math 135, what's up? In this video we're going to be looking at some extra examples from section 8.5 on the normal distribution. You should have your z-table in order to compute some probabilities. Your z-table should look something like that. So go ahead and grab your z-table if you don't already have it, and then we'll go ahead and do some probabilities here. Remember a capital Z, we use that to represent our standard normal random variable. All right. And so in the first question, they're asking what's the probability that our standard normal random variable is less than 1.84. So looking at our picture here, remember each tick mark represents one standard deviation away from the mean. So positive 1, 2, 3 on the left of the mean, and the mean here is 0. So remember our standard normal random variable has a mean of 0 and a standard deviation of 1. Okay, geometrically, 1.84 would be somewhere around right there. Z equals 1.84. And the less than probability corresponds to the area to the left, under the curve, to the left of that value. And these less than probabilities are the ones that are shown on our z-table. So on the z-table, we want to find 1.84. So we got to go to the positive side of the z-table, find the 1.8 row, and then go over to the 0.04 column. And it looks like 0.9671 is the value that we're looking at here. Again, in the 1.8 column over in the 0.04 row. And that's it for our problem. What was that number again? As soon as I clicked over here, I lost it. 0.9671. All right, so when you're asked to find probabilities, finding the less than probabilities, just a matter of looking up things on the table. For the next one, the probability that z is more than 1.05, again, over here in the picture. Sorry, negative 1 and negative 2. 1.05 is a little bit bigger than 1. And greater than, we're looking, this corresponds geometrically to the area to the right. Now there are a couple of ways, remember, to deal with this. One way is to use complements. The complement event would be the left or less than event. So this would be 1 minus that event, 1 minus the probability that z is less than or equal to 1.05. And this less than problem is one that we can look up on the table. All right, so on our z-table, we got to find the 1.0 row, and then over to the 0.05 column, 0.8531. And after the subtraction, you get 0.1469. All right, now that's my favorite way for dealing with the greater than problems. There is another trick that you can do. If we find the opposite of 1.5, that would be negative 1.05. And if I look at the area to the left of that, by symmetry, the blue area here is the same as the red area on the right. All right? So we could use a symmetry argument to say that our probability here is the same as the probability that z is less than negative 1.05. And if we were to look up that value on our z-table, we're looking up, let's see, we got to find the negative 1.0 row on the negative side, negative 1.0 row, over to the 0.05 column. There it is, 0.1469. Okay, so like I said, the complement strategy up to this point in my experience with the normal distribution, the complement strategy has been my favorite, but this symmetry strategy is quickly thinking about taking its place. For the, again, that's the greater than problem. Notice that both of these strategies, we turned our greater than problem into a less than problem. Okay? The less than problems are the only ones that we can solve using the table. All of the other problems, we have to find some way to change it into a less than problem, or a pair of less than problems like we have in part C. Okay, so in part C, the probability that our standard normal random variable takes on a value between negative 2.16 and negative 0.11. So we can find these values here on the table. Negative 2.16 will be maybe right about there. And negative 0.11 be close to 0. And we're looking for the in-between area, the area in between those two values underneath that curve. Now the way this problem is solved is we look at, if I shade in the blue area here, that's the area to the left. That's the area to the left of negative 0.11. Negative 0.11. And we can look that up, we can look that value up on the table. But there was this little tail over here that I counted a little bit too much. I'll shade that in with awful green. That green area, that's area that we didn't want to count. But that's the area, so if I want to get rid of it, that's the area to the left of negative 2.16. But that's also a value that we can look up on the table. All right, so let's look up both of those values on the table. Find the negative 0.1 row, and then the 0.01 column, 4, 5, 6, 2. And then the negative 2.16 entry. Find the negative 2.1 row, then over to the 0.06 column, 0.154. And then after the subtraction, you get 0.4408. Okay, so those are our three kinds of problems that we have to do here. There's our less than problem that we just look up on the table. There's our greater than problem, where we have a couple different options for turning them into less than problems that we can look up at the table. And then there's our in-between problem that we turn into a pair of less than problems where we take their difference at the end. And so the key thing here is to just know how to deal with each of those three problems. Have a way that works for you that you can remember to do those problems. And then that's all there is to it. So let's do a few more here. For part D, looking at the probability that Z is more than negative 1.36. And I think the pictures here, the only reason that we're really focused on these pictures is so that you can understand basically this complement strategy or the symmetry strategy, okay, or the in-between strategy that we do. The pictures really help you to understand the strategies. Beyond understanding the strategies, the pictures I don't think are super helpful. I guess they are kind of helpful for doing reality checks. So for instance here, we find negative 1.36 to be about right there. And we're doing a more than, so we're finding the area to the right. Now, when I talk about reality checks, remember there is some symmetry here. So the area to the right of 0 is exactly 1/2. The entire area under the curve is 1. The area to the right of 0 is 1/2, as is the total area to the left. And here we can see that our red region is more than 1/2. So we know that our answer should be more than 1/2. Using our complement strategy here, this would be 1 minus the probability that z is less than or equal to negative 1.36. And so we have to find the entry corresponding to negative 1.36 on our z table. So find the negative 1.3 row over to the 0.06 column, 0.0869. Sorry, 0.0869. And that should give us a value of 0.9131. If you like the symmetry strategy, then we would be looking to find the probability that z is less than positive 1.36, and that should be the same value on your z table. We're not doing 1 minus that, we're just looking up this value. So again, the key thing is you don't have to understand all the different options. Some students prefer the 1 minus, some students prefer the symmetry, but find an option that works for you that you can remember to do, and just do that. All right then, for part E, probability that z is less than negative 0.72. Negative 0.72 would be right about here. And this is a less than problem. And so we can just look this one up on the table. Find the negative 0.7 row. Negative 0.7 row over to the 0.02 column. 2358. And then finally, one last in-between problem. We have z is in between 0.27 and 1.61. There's 0.27 and 1.61 would be right around there. And so this is an in-between. Now here we can also see that our answer should be smaller than 1/2 because the region is entirely contained in this side to the left of to the right of 0. So our answer should end up being less than 1/2. And the strategy here is to say, find the probability that z is less than 1.61, and then subtract the probability that z is less than 0.27. So we have a couple values to look up on our z table now. Let's see, we got to go to the positive side. 1.6, the 1.6 row over to the 0.01 column, 9463. And then 0.27, we got to find the 0.2 row. 0.2 row over to the 0.07 column, 6064. Right, and then after subtraction, we get 0.2859. Doesn't seem right. That was an answer that I had written down. Let's make sure I let's make sure that doesn't look right. I must have made a mistake when I wrote down my answers. Let's double check. Double check that I looked up the values correctly on the table. 1.61. 1.619463 and 0.27 6064. So I guess I got to bust out my calculator. All right. 9463 minus 6064. 3399. I'm not exactly sure what happened there. Okay. So our standard normal distribution problems, once you've done a few of them, they're pretty, I think they're pretty straightforward. My experience, students don't struggle with those unless they haven't been doing the work. On the next page, we have some backwards problems. We're again told that z is our standard normal random variable. Here, instead of trying to find probabilities, we're trying to find values of z. And just like on the first page, our less than problems are the ones that we can use our z table for. The idea is that we're given a probability. The probabilities are the values on the inside here. So we've got to look up a probability first. So we got to find 0.8980 somewhere in the middle here. 0.8980, there it is. 0.8980. And then the z value, we got to find the z value that corresponds to that. The z value here, we're in the 1.2 row and in the 0.07 column. So we got 1.27. Part B is another less than problem. So we'll just whip out the z table then. We need to find 0.2206. Now 0.2206 is smaller than 1/2. Notice that everything on the positive side, for all the positive z values here, everything's bigger than 1/2. On the other side, where all the negative z values are all the numbers, all the probabilities that are smaller than 1/2. So since this probability is smaller than 1/2, then we can go straight to the negative side. And we're trying to find 0.2206. There's my 0.2296. There's 0.2206. We're in the negative 0.7 row and the 0.07 column. So that'd be negative 0.77. All right then, on to part C. The probability, we're given the probability that z is greater than negative z is 0.9893. Now here's where I really like the symmetry strategy. This probability here is the same. This is a janky equal sign. That's the same as the probability that z is less than negative z. That's our symmetry strategy from the first page. Okay, if we want to think about a picture that corresponds to this situation, there's my 0. Now since this is a greater than problem, it's an area to the right, and since that's a big area, then we know that negative z is over here somewhere. And this is the area that we're talking about. If we go find the opposite of negative z, which would be over here, actually that would be just z, and we look at the area to the left of that, the red shaded region and the blue shaded region, they overlap for one, but they're the same. It's just that the blue shaded region has this little tail area over here, as well as the overlap, and the red shaded region has the same area tail, but on the right side, along with the overlapped region. So again, that's why this symmetry strategy works. So I really like the symmetry strategy here. Okay, so since these two probabilities are the same, then the probability that z is less than z is also 0.9893. And now we have a less than probability. We can go to the z table. And find 0.9893. We know, since this is bigger than a half, that we want to be on the positive side for z. Negative z was on the left, but positive z is going to be on the right. 9893. There's 98. There we go, 9893. 2.30. Okay, finally, for D here, I don't know why that moved. There we go. We have another less than, and the less than problems are the ones where we just jump straight to the table. We don't have to do any work. We just jump straight to the table. 9893, we just looked that up. I lost it. There it is, 9893. And so the challenge here, we got 2.30. The challenge here is that it's negative z. All right, the value that we're looking at here is negative z. So negative z is equal to 2.3. So that means that positive z is not really positive, but z itself is negative 2.3. Okay, so those are our backwards problems with our standard normal random variable. They're definitely a little bit trickier than the ones we did on the first page, but I think the in-between problems are the ones that are really hard. So as long as we can focus on the more than and the less than problems and know how to deal with those, the more than problem are really they're the only real challenge here, I guess. Okay, finally, on the last page here of this worksheet, we have x is a normal random variable. It's not standard. It has this particular normal random variable has a mean of 500 and a standard deviation of 75. We want to find the following probabilities. When we have just a generic normal random variable, then we have to find a z-score. So the formula for the z-score here would be z is equal to x minus the mean all over the standard deviation. And in this first problem, when I plug in the values, the little x value here is 650. This value right here, 650 minus the mean that was given is 500. Standard deviation is 75. And when you work that out, you should get a z-score of 2. And our strategy for dealing with these generic normal random variables is to rewrite our probability about x in terms of a probability about z. And the corresponding probability here would be the probability that a standard normal random variable is less than 2. And now we're back into a problem from the first page where, since this is a less than problem, we can just go ahead and look up that value on our z table. Let's see, it's just 2. So we got 2.00. And the corresponding probability is 0.9772. So when it comes to dealing with normal random variables, I think the challenge here is like trying to memorize a bunch of steps. But I think rather than doing that, I think of this problem as having one step. That is, convert your probability about x into a probability about z. And then you jump into, all right, what do I do about probabilities about z? And we're back to doing the things that we did on the first page. So I guess maybe it's 2 steps. Find a z-score and then do whatever you would do with this problem. So we'll do a similar thing for B. Find a z-score for 300. So we're doing 300, that's our x value here, minus the mean of 500, divided by 2. And here we'll get a z-score of 2.67. We're always going to round our z-scores to 2 decimals because that's what our z-table gives us. The z-values on our z-table are expressed to 2 decimals. All right, so our first step here, where we express this probability about x in terms of a probability about z, that would be the probability that z is greater than 2.67. And now we got to remember how to deal with the greater than problems. So I will write this, I guess I'll just use the complement strategy here, b1 minus the probability that z is less than or equal to 2.67. And then I got to find 2.67. This was negative 2.67. I'm not copying my notes down correctly. Negative 2.67. Sorry about that. I got to find negative 2.67. Since 300 is less than the mean, that's kind of how I caught myself here. 300 is smaller than the mean. And so its z-score is going to be negative. Remember, the z-score tells you how many standard deviations you are away from the mean. So the value of 300, the value of 300 is 2.67 standard deviations less than the mean. All right, so we got to find negative 2.67 on our z-table. Now we're doing a z probability. Negative 2.6 row over to the 0.7 column, 0.0038. So we're doing 1 minus 0.0038, and that gives you 0.9962. All right, part C. We have an in-between problem. There's actually 2 z-scores that we need to find. For the first z-score, I guess I'll call it z1. We'll take 250. That's our x minus the mean of 500 all over the standard deviation of 2. That'll give you negative 2. And then the second z-score that's relevant, we're going to use 700 for the x value. 700 minus the mean all over the standard deviation. Man, I'm not copying my notes down very well at all. Sorry about that. Standard deviation is 75, not 2. Okay, and this gives us 2.67. Again, when I round my z-score to 2 decimal places. And then our translation here from an x probability into a z probability. This is the probability that z is between negative 2 and 2.67. Okay, so we have an in-between probability. For the z-scores, that means we do the probability that z is less than the larger value minus the probability that z is less than the smaller value. And we have now a couple of values that we have to look up on the z-table. 2.67. Go find the 2.6 row. Over to the 0.07 column, 2.6, 0.07 column, 9962. And then the probability that z is less than negative 2. We got to find negative 2 on our z-table. and the corresponding probability 0.0228. All right, then we have to the subtraction problem. 9962 minus 228. We get 9734. Okay, so in A through B, we're finding probabilities, and the corresponding steps are basically find a z-score or z-scores so that you can express your x probabilities as z probabilities, and then do the z probabilities like we did on the first page. In D and E, we have some backwards problems. And so the strategy here is, well, we know that each x value has a corresponding z-score. And we know that the corresponding z probability is the same probability. So now we have a backwards problem involving z's. We can go ahead and use our z table. Now 0.6 here is a probability, so we have to find a number. See, 0.6 is bigger than a half, so we want to be on the positive side. Now there's not a number on here that's exactly 0.6. I think the two closest here are 0.5987 and 0.6026, and let's see, 5987 is a little bit closer than that. So we're going to go ahead, we're in a 0.2 row, and then the closer of these two values corresponds to 0.05 column. So our z value here is 0.25. And then we go ahead. We know three pieces here. We know of our z-score formula. We know the z-score, 0.25. We know the mean, 500. And we know the standard deviation, 75. And then we just got to solve for x. So we'll multiply on both sides by 75. And then add 500 to both sides. And that'll give us our x value. And you should get an x value here of 518.75. And then if you want, you can go ahead and check. Go ahead and say, oh, okay, probability that this random variable takes on a value less than 518.75, you can go ahead and find the z-score, and you'll find the z-score is 0.25, and look up 0.25 on the table, and it gives you this probability. All right, finally for E, we have a greater than problem. And I guess I'll use the complement strategy to deal with this greater than problem. The probability that x is greater than, the probability that our random variable takes on a value greater than x, that should be, if I look at the probability that our normal random variable takes on a value less than x, that should be 1 minus 0.05, which is 0.95. Now there is a corresponding z-score, and the probability that a standard normal random variable would take on a value less than that z-score will also be 0.95. So now we have a backwards problem involving a standard normal random variable. We can look up, try to find the number closest to 0.95 on our z-table. And here, looks like there's two values that are equally far away from 0.95. And so here, I guess I'll just kind of go right in the middle. All right, 1.6, I'll call this 1.645. Since both of these values are equally far away. And I guess actually what I'm going to do is, I think technically in this case you should, when there's this right in the middle business, you should round closer to 0. So we should actually be rounding this down. So actually I'm going to go to 1.64. Z is 1.64. Due to the nature of our curve that we're looking at, we should round things. We should round z-scores. Basically, z-scores at a half, we should round them closer to the origin. So round a half, like round 1.645 down to 1.64. Okay, so we get a z-score of 1.64. Now we know our z-score. We're trying to find our x value. We know our mean is 500. That was given way back at the very beginning of the problem. And the standard deviation is 75. And when you solve for x here, again, it's a fairly straightforward two-step equation. You should get x is equal to 623. All right, that'll do it for this video. The backwards problems involving x's, those are definitely pretty challenging, and so you want to take a second to think about our strategy and what we're doing here. If you have questions about what we're doing, please make sure you ask. And the backwards problems in general, I think, are the most challenging thing. Once you get the hang of it, all of the probability problems here, I think, are very straightforward. And in my experience, students are successful with them. So if you do have questions, please make sure that you get them answered because you want to also be successful with these problems.